Hello, I'm Robert, and I'm speaking for Doomsday Debunked, where our aim is to tell you the truth, find out the truth behind the stories that scare you, and with no sugarcoating, but just telling you things the way they are. So this was one that was asked today, and this looks very scary. Climate emissions from tropical forest damage underestimated by a factor of 6. Then you go down, and it says that the research led by the University of Queensland find the climate impact of selective logging, outright clearing and fire in tropical rainforests between 2000 and 2013 was underestimated by 6.53 billion tonnes of CO2. And it says likely conservative. And that sounds like an awful lot. But the first thing you need to think about is that actually it's over 30 billion tonnes of CO2 a year from human emissions. So when you get these big figures of billions of tonnes, you need to remember that actually it's a very big figure that we actually produce. And that works out as being, I work it out somewhere here, what percentage it is. It's 500 million a year compared with, so it's a little bit under 2% of total human emissions. But if true, that was very significant. But what this is missing, and I found out all sorts of interesting stuff kind of falling through, reading the paper, and then reading other papers that said other things. I found all sorts of interesting stuff, which is what I want to share with you. So, first of all, if you drill down to the paper itself, it's not very clear from the Guardian article. They're just talking about the effect of cutting down virgin intact forest and what difference it makes. If you look at the forest, and when you cut down a forest, there's the amount of carbon that's actually inside the forest itself, that's embodied in the living plants in the forest. And then as well as that, when you have a forest, then some forests are losing mass, some are gaining mass, but overall the intact forests are generally gaining mass as time goes on. And so they're doing constant carbon sequestration all the time. And so if you cut down the forest, you're not only cutting down what's there, but you're cutting down the potential for more carbon that could have taken from the atmosphere in the future. And that's especially so because at the moment, I think it's because of the carbon dioxide fertilization effect, because the carbon dioxide levels going up has led to trees growing more and producing more leaves, and they're actually taking up more and more as the carbon dioxide levels go up. So if you cut down the forest, then it's no longer able to do that. However, it doesn't take account of what the forest gets replaced by. And so if it gets replaced by crops, then that's one thing. But if it gets replaced by reforestation, then a new forest, a young forest growing up, is going to take out far more carbon dioxide from the atmosphere than an old growth forest that is just growing a bit more because of CO2 fertilization. And so that's what it turns out they haven't taken account of. So I got to go through some details there. And then if we go down, these are some figures from this is the other paper I found. It's a very interesting one. And you look, this is a young growth forest, and that's the amount that it takes in per year. And as it gets older, that's less than 20 years. That's what's the red and the blue? Anyway, let's zoom in a bit. That's less than 20 years. That's greater than 20, and that's old growth. I'm not sure what the red and blue is. Let's see if I can find the article. I should have brought that up. But you can see the huge reduction from the young that's the young growth. That's 0 there, and so the old growth is just a little bit of a smudge upwards. That's the amount of carbon dioxide for the old growth. And then young growth, you compare, remember the 0 line is there, not there, then it's a huge amount more that you've got for the young growth trees. And they've got a little summary up here somewhere. Younger secondary forests, in Asia it was 3.4, in Africa varying up to 7.6 in Africa. And these are tropical rainforests. For older ones, varies from 2.3 up to 3.5, and old growth from 0.7 to 1.3. So that 1.3 compared with 7.6, you can see it's an awful lot more rapid taking up of the carbon dioxide in the younger secondary forests. And that's just for the biomass above the ground, the living biomass. It doesn't take account of the soil, but it's much complicated. It depends on the type of soil. And they just said to look at the methods given by the IPCC. This actual article was about changing the IPCC. The IPCC has these figures written into it that you use for working out what your credits are, but they're still really working out quite how to use the forest, but they still have the how to take account of them. But that was one of the things that wasn't very completely sorted out in the rule book in the autumn of 2018. But they're going ahead anyway. But with everything else, this is a bit of a grey area still. Anyway, they're suggesting these higher figures for the forests, and they're still working out how to actually use this for in practice in the future. There'll be more discussions about that. It's not completely worked out. So anyway, so then I found that, and then I went on and I found this other paper which is really interesting, a recent study in 2019, and this looked at Brazil, particularly Brazil, but of course Brazil is very important for its deforestation. And what they found, it was one of these integrated modules that try and take everything into account. So it's looking at the future demands, the future increase in crop yields, and the future what's going to affect on the land area. And they found that, and during this integrated model, they found there should be a turnaround in 2020. According that you can do lots of different models with different assumptions. So it doesn't mean it's definitely going to happen in 2020. But the assumptions they looked at, which were pretty much middle of the road assumptions, based on the various models of this type that's being done, then they found that crop yields are growing on average 1.5% per year. And because of better ways of doing crops as well as this fertilization effects, but everything integrated, then it's 1.5% per year. And the meat production, and both of these are rather low. The crop yields and the meat production is rather low in Brazil, so it's partly coming up to the norm, like what you could do in the States on the same land. So the crop yields they think will grow about 1.5% a year. The meat production they think will intensify to 1 to 1.7 heads per hectare by 2050, and the food intake then this is also growing, and it's 17.3% by 2050, and they think that the increase in demand for the meat products in Brazil will go up to 29.3% by 2050. So then putting this into their model, and the regions with highest demand growth are the centre-west, they give us 36.5% food crops, 48.2%, and so there's some parts of Brazil, and this was a region model, it's a very detailed model compared with kind of global models. It was specific for Brazil, and so they then came up with this figure, and as you can see, that they have this slightly decreasing agriculture, and agriculture pretty steady. It's the pasture that's particularly being decreased, but the agriculture isn't being decreased as well. You can't really see it very clearly on that picture because there's only a small decrease for the agriculture and a stronger one for the. I remember this is kind of cumulatively added up, and then you have the sugarcane, and then you have a forest of natural vegetation, and the forest has been decreasing from 2010 to 2015, from 2010, and when it gets to 2020, they think that the I don't know, where do they say? I think they say that around then that the forest reaches wait a minute, the natural forest, most of that in the first 15 years from 2010 to 2025. So from there to there, that's when the forest deforestation is going to continue for another 5 years through to 2025, they think. But you already, because of the improving crop yields and then the improving particularly also improving of the heads on the pasture, there'll be this land being freed up. And I think it'll already start being freed up in 2020, and that there'll continue to be more and more land freed up. For some reason, the freed up land there's freed up land already, even with deforestation continuing. There's going to be freed up land from 2020, and then it continues to get more and more. So what they were thinking, what they looked at then is, what are we going to do in Brazil with this freed up land? And they looked at just two possibilities. It's not meant to be realistic. Realistically, we're going to do all sorts. Brazil is going to do all sorts of different things with this freed up land. But they looked at two possibilities. What if you used all the freed up land for sugarcane? That's not actually going to happen. There's some kind of limit on sugarcane anyway. But if you used all for sugarcane and use that to make ethanol, obviously you'd do it for sugar as well, but most of it used for ethanol, which we'd use for bioenergy, carbon capture and storage. So using all that land just to capture carbon and then you burn it and you store and you keep the CO2 emissions. And then the other thing you could do with that land that they looked at in their 2 case studies was reforestation. Return it to the tropical rainforest or as close to it as you can over a period of time as first primary forest, then secondary forest, and eventually over a long period of time it will become old growth forest again. And so if you look at those two possibilities and then look at what happens to carbon stock, so at the moment it's decreasing because of deforestation. But if you were to use all that, and if you didn't use any of that land, it slowly decreases all the way down. If you just assume that land is just nothing happens to it, it's just abandoned. If it's just abandoned and nothing's growing there, it's basically, I suppose it would just be sort of scrubbing grassland. Then that's that grey thing, and it just keeps, because there's more and more land that is just being abandoned and isn't doing much carbon sequestration, then it just keeps decreasing the carbon stock. This is the total amount of carbon that is stored in all the agriculture in Brazil. Now, if you start using a sugarcane expansion, you cover all that land as it's freed with sugarcane, then it sort of levels off and it slightly goes up, but it's still below what it was originally, but not a huge amount below. It's sort of pretty much at its 2025 levels or so, and then it goes up very slightly. But if you particularly reforest that area, going towards a tropical rainforest, but you start with very fast growing trees, and you clearly reforesting more and more of it with fast growing trees, then you end up with a more stock in wood than you had in trees than you had at the beginning. Because although you have cut down a fair bit of the rainforest, but there's of course there's vast amounts left, and then you've actually expanded. This would be a larger area of your young growth than you lost originally, because so much agricultural land is being freed up. And so the reforestation would recover the original carbon stocks of all the failed forests between 2010 and 2025 by 2035 in just 10 years, and it's been failing for 15 years. And then if you use sugarcane, it doesn't work so well. And so that really shows that you're expanding on biofuel, at least with sugarcane, is not going to be the most effective way of taking carbon dioxide out of the atmosphere in Brazil. It's far better just to reforest. You can think of many other things you could do. I mean, you think if you've got these rapidly growing forests, then maybe it would be very effective to grow timber and then burn that as biofuel and energy and storage as some of it. And that might, that obviously, if you then capture the carbon dioxide and you keep having the rapidly growing growth, because remember, the rapidly growing growth is at the very beginning, and then after 20 years, it's going to be less effective. So if you could cut it down there, and not all of it, but you have regions that are commercial forests, and then you burnt it and then use carbon capture and storage. They don't look into that, but that surely would give you even more. But over this time period, it's only from 2025 to 2045, that's 20 years, it's still young growth forest. This is now secondary forest. It'll be quite a long time before it becomes old growth forest. So that's looking very promising, and I mean, so you get from this idea that cutting down these forests is going to be a huge knock-on, really bad effect on our carbon budget, even if it's only 2 or 3%. But if you look at the particular case of Brazil, and if you do reforestation, you can completely turn that around, and you actually regain everything you lost from the time when the forests were cut down, and then you're continuing with gaining carbon dioxide faster than you were originally in the original old growth forests at that point in these extra areas. So and now I just added some extra bits from my previous articles. So if you've seen those, then you may have read this already. But I'll just go through that because it's quite an interesting thing. First of all, a lot of people worry about all this publicity about a tipping point in the Amazon. It turns out this is rather older research. We use models with just two functional types, and no range, and all the trees the same age, and nothing about nutrients. And the more recent models have been able to be much more sophisticated with a diversity of vegetation, and they find that it changes in patches. So even if we're not expect to get a sudden change, that all the forest turns to savanna. It's not going to turn to desert no matter what happens. And the western Amazon is very wet, and no matter what happens, that's not going to be gone unless you fell it. It's just there, even like 3 degrees, 4 degrees C. We still have a big area of wet Amazon in the western rainforest. But the eastern part of it, as it dries out, then parts of it can, especially if we went all the way up to 2 degrees and 3 degrees, then parts of it could start turning into savanna, which is still, I mean, it's a very interesting habitat still, but it's not going to patch on the original tropical rainforest. And the tropical rainforest, the thing is, it's wonderfully biodiverse, so we mustn't forget that. It's not just cutting down forests and replacing them with other forests. You have trees there that just little patches. You might have a 24 square kilometers, and that's all that species is occupying in the rainforest. And then there's another species, there's some other species that's a little bit further along. It's different. It's been there. It's wonderfully diverse because it's been very stable for hundreds of thousands of years. I don't know, it's millions. I'm not sure. It's very ancient. The Amazon rainforest, parts of it. And anyway, now I better talk about. I'm going to try and remember. I tend to digress a little bit on these talks, and I should keep to what I researched for it because that's very current in my mind, so I can tell you that accurately, and I might get a bit inaccurate if I go on to any of these diversions. So anyway, so the forest fires. But one thing that people don't realise is that forest fires actually have a fertilising effect, and so all these, especially in Africa. And Africa has an awful lot of burning of, you see these in the news, and the burning of grassland in Africa. That's just part of the natural cycle in Africa. And it's an awful lot of it is grassland rather than wood, trees. Same in Brazil. And recently discovered there's been a bit of a mystery of how Amazon gets some of its fertilising, the nitrogen and other things that it gets. And it comes from, we now know, it used to be thought it came from Sahara dust. There's a small amount of that. We now know that an awful lot of it comes from fires in Africa. So fires aren't quite the negative thing that you think. They're part of the natural cycle of life, but not in a tropical rainforest. Tropical rainforests don't burn down, but they're just too wet for that. But other kinds of forests, they do burn, and actually the Amazon rainforest is actually flourishing partly as a result of fires in Africa. And the fires in Africa are part of the natural order. There's some that are rainforests and stuff, and they're not so good. But some of them, we have to remember, fire is part of how the world works. And it's been like that for billions of years. Right now, so this is just for my other parts of the. There's about how ranching could be much more productive. We already came across that in that projection, and that's supposing just a linear increase. but with a special push into becoming more productive. That could be done more quickly. That was an increase from 1 to 1.7 by 2050. Here's an example of cattle rancher who increased from 1 to 2.5 in just a few years. So it could be much faster than that if you had to kind of push into being more efficient with your cattle ranching. And then another example, you can actually restore large areas of this is a family that restored large areas of their land to tropical rainforest. Switch off the sound. I just leave it running. This shows some of the restored land, I think. And so this is all they just restored it to. That's it, the old stuff, and then you end up with the trees and everything like that. It's due to terror, and these are some of the species that you find coming back, and some of these were quite rare species. 33 species of mammals, 172 species of birds, and some of them listed as vulnerable. I mean, vulnerable is just a 10% extinction in a century level. It's not. I don't know if they had any of the actual endangered species there, which is much higher bar. But still, I mean, it's very nice to see these vulnerable creatures being given a new home. So this is something you can do. Okay, you're not going to be able to recover any species that were actually lost when they felled the rainforest, but you can encourage the ones that are there that are still quite rare. And look at all these wonderful creatures that they got just by restoring they planted 2 million species of 290 species of trees native to this forest. I think was that rainforest? I'm not sure. But you can do the same, and now this is also another thing, that you can replant the grassland to increase the productivity, and you might think that's surely in Brazil they must replant the grassland, but they don't. And this is a kind of a obvious thing to do, which people would be doing in the States by matter of course, and that makes a huge difference to the productivity. You can see the difference between those two sides. So that's a very simple measure. That it's currently only a third of its sustainable potential if you compare it with the. So in principle, it can meet its entire demand for beef, crops, and timber through 2040 by increasing its productivity from a third to a half of the sustainable potential. Just a small increase. So there's really a huge amount you can do. Now the problem is that they need an investment for replanting. Then that's expensive. It's quite expensive for a poor Brazilian farmer to do that. And so part of this whole thing about trying to get Brazil to turn from that to that is to find a way to mobilize investment, and with a longer payback time. And loans are expensive and they can default on them, or finance or investment, then how do you get to it? And so there are various companies who are working on this, on sustainability and traceability, and then this is the Novo Campo program, and these have the idea, and this is a rather carefully worked out program that is now being used in various parts of the Brazilian Amazon, and they divide the ranches into different areas. They have an intensified area with pasture reform and management, so that would be doing all that replanting. And then they have supplementary feeding for livestock in the dry season, keeping the livestock away from rivers, and that lets the natural forests grow up along the rivers, which is a natural place for the forests. So that's actual natural. So that gives you then these little corridors where all these wonderful species can survive in, and rivers are very natural corridors for species to move along, because they're continuous all the way to the sea, and so then you get these areas like that, and these show the different mixes of, like the natural forest in the background and the grassland in the forward with the animals, and then they also have reforestation with commercial timbers. So, and another thing about going along the rivers is that some of the original trees may exist already, may not have been cut down along the rivers. So it's partly recuperation using some trees that might be there already. And then you have reforestation with commercial timbers, and that also gives shade for the animals. So this is partly showing that the animals partly shaded by the trees. So you would have commercial timbers which give extra income. So trees provide shade for the animals and extra income for the ranchers. So you have those three layers. You have the natural regrowing forest, tropical rainforest along the rivers. You have the livestock being kept away to help from the rivers to help them do that. Then you have the also trees with commercial timbers, which would be further back from the rivers, and which give shade for the animals and extra income for the ranchers. So I assume that this is commercial timbers. I don't know very much about species in Brazil, but it looks like this is all three. That would be the animals and the grassland. These would be commercial timbers, and in the background the natural rainforest would be along the river. And so, and the various other initiatives, and there's some videos you can watch about that. And this is part of the Global Bond Challenge. Launched in 2011, they aim to restore 150 million hectares worldwide by 2020 and 350 million by 2030. That's 1.5 million square kilometres and 3.5 million, yes, so you just divide by 100 and you get square kilometres, convert hectares to square kilometres. And that's an area, by 2030, that's an area 3,500 kilometres by 1,000 kilometres of that they aim to restore in this kind of a restore as forest. That would just be the forest part of that. And here are some of the places. Now, this mightn't necessarily be always that you actually can do it, but this potential forest lands, they have that atlas here, forest landscape restoration opportunities, and there's a paper there about it, and whether all of those can actually be reforested. Now, for instance, I live in the UK, and they obviously have shown that as being quite a high level of wide-scale opportunity reforestation. In the UK, over Scotland, we have these mountains which used to be covered in Scots pine, and there's a Scots pine restoration project in Scotland. And you can also have commercial timbers, but you can also restore the native forest of Scots pine, which involves very similar to the way it's done in other places. We'd have to keep animals out of the Scots pine so they don't keep eating them. We have many stands of Scots pine in Scotland. If you go and look at them, you often find that there are no young ones beneath them. They're just the old trees, and they're not going to. Then once those old trees have died, which can take a long time, there won't be any more new Scots pines come along, unless you kind of fence it off from animals so that the young Scots pines can grow. So there's reforestation programs going on in Scotland, and one thing to put this into perspective, then what they are all this reforestation, all this work in Brazil, and they started off completely covered in forest. Some of the areas that were completely covered in tropical forest, they end up with this mix of grassland, commercial timber, and the original forest. Well, places like the UK where I live, it was originally all forest, just like Brazil was. And now we have very much like this, a mix of grassland and animals and some crops, like they have in Brazil, and commercial forest, and we have little patches of the old forest still here. But we don't have very much, not nearly as much as Brazil has, of what used to be, because we've lost it over thousands and thousands of years. So now the Brazilian forest is rather remarkable because it's so biodiverse, far more biodiverse than Scotland was. Our forests have got very little history compared with Brazil, the Amazon rainforest, because Scotland was completely covered in ice during the Ice Age, and all the trees here just grew up after the Ice Age. And then we came along and first of all there was the ice, then there was the tundra, and then there were our forests. Then we came along and cut down most of our forests and had trees and cut them down, burnt them, turned them into agricultural land, and then had animals go and graze, which got rid of many of the remaining ones. And we used them for making boats, and we used them for making charcoal. We had an awful lot of forest was cut down for charcoal. So that's all in the past in the UK, and now we are in the other direction, and our forests are being restored. And it seems that in Brazil, if they're right, then according to this projection, then the Brazil's, if you go up to that thing, then the Brazil's what the equivalent of our past is maybe going to end about 2025. And from then on, then they would be back like us, actually reforesting. And that is a possible future if they reforest this grey area. That's a possible future using this model, which is their best estimates of it. It is a fairly mainstream model. You can go and look at the paper. I'd be interested in any experts what you think about it. It's a very interesting paper, and if you have a look at this, you can look at all the other links that I have to all these different things. And that I think is that. Oh yes, and so the forests, they're a treasure for all of us, but saving them has to be part of a global solution where we work together at all levels, local, governmental and intergovernmental, and also changing our lifestyle on a personal level to restore the planet and return to a sustainable way forwards, which also involves recognising the knowledge, innovations and practices, institutions and values of indigenous people and local communities. I mean, a lot of this work in Brazil, it is actually local people are involved in that. They come up with creative new solutions. It's not being done, it's not being kind of foisted on them from above. There are these partners that are enabling the finance and trying to help with the finance and bringing in new ideas that they hadn't thought of, like, for instance, planting the ranches. But this is combined with innovations on the ground. It's the people on the ground definitely have to be involved in this. It can't be done as a top-down thing, because you need local knowledge and understanding, and it's never quite the same. Farmers know that every bit of land is unique in some way. Now you have to be really not even 1 hectare is quite the same as another. And so that's the vision of the best report, which I covered a few months back, and I've got some more positive things here you can read about 24 ways the world is better, and this is one of them. All this work being done, we heard so much about Amazon fires. How many of you have actually heard about these projects going on? These restoration projects that are going on in Brazil today. You get a sentence or two in some of these stories. Mainly news of someone whether not to give them funds because of one of the projects, because of Bolsonaro's actions and stuff. You just don't hear about all the positive stuff. It's so rarely mentioned on the news. And so I have there, and then these other things, positive sides of climate change facts. I mean, we're just doing so much in just the last 4 years since the Paris Agreement. There's so much going on around the world. Really, people are really acting, and you would never guess it from some of our news stories. So, anyway, hope you enjoyed that. And any questions, do say. If I've made any mistakes in this, do say in the comments. And or if you've got anything extra that needs to be added, some interesting papers or stuff, then do say.